and her mentor, Deepa, will introduce her.
Hi, everyone. I'm Deepa Kalkunte, and I've had the pleasure of mentoring Julia. And she is a 7th grader at GMS. And I will admit, I had a hard time remembering she's only 13. She was so mature in thought, both in thought and action throughout the mentorship. And her wit was just amazing throughout the mentorship as well. She made me chuckle many times, and I was just amazed and impressed by her rapid grasp of many concepts. She joined Magic with a passion to learn and challenge herself by finding something very difficult to work on. And she did that and more with, by learning Python as well as Raspberry Pi. So with great pleasure, I present to you Julia and her project.
Okay, hey, I'm Julia, and I'm a 7th grader at GMS. Next slide, please. Okay, my mentor's name is Deepa Kalkunte. She's an engineering manager at Discover Financial Services and resides in Richmond, Virginia. She enjoys playing tennis and solving crossword puzzles in her spare time. Next slide, please. I titled my project Learning Python because I'm designing a program in Python, which is a programming language, and running it on a Raspberry Pi, which is a single board computer with a 64-bit OS, the same as a MacBook, actually. I chose this project because I wanted to work with hardware and software, and I wanted to use something with visual output. I aim to build a Morse code translator in Python and run it on the Raspberry Pi. The Morse code translator takes a string given by the user and translates it into a Morse code message with dashes and dots. By connecting the Pi to the LED, the program flashed out the message. The programming required an understanding of the problem to write the logic, and knowledge of Python data structures such as strings, which are text variable, dictionaries, which hold key value pairs, functions, which are reusable programs, and for loops, which can repeatedly run a piece of code, in this instance, for each character in a string. Building the Python translator took a while, as I had no preliminary knowledge of Python. Next slide, please. The hardware necessary for the project included the Pi and its external accessories, the keyboard, mouse, and monitor, and the GPIO pins on the Pi, which are pretty much little metal sticks that can send an electrical current and be activated programmatically. 2 jumper wires, which carry the electrical current from the GPIO pins in use, and a green LED. The Python program includes GPIO setup and pin activation to light up the LED. Next slide, please. I learned a lot while building my project, including that I should always start with the basics. I started with a relatively challenging project, and then went back and took some Microsoft lessons on Python. After the lessons, the code we had written made a lot more sense. I also had to do a lot of testing while building the program. I spent many hours debugging the program and modifying it until it was fully functional. After writing the full program, which I did on my school computer, I had to transfer it to the Raspberry Pi. The Pi required a lot of cables to connect the keyboard, mouse, and monitor. It also wouldn't actually boot up the first many times I tried, and I ended up having to get it replaced. We actually still don't know what had went wrong with it. Then my program had to activate the GPIO pins. This took a long time because the GPIO code for the Raspberry Pi, which is the model, for the Raspberry Pi 5, which is the model I got, needed special instructions. We found a setup that worked and connected the GPIO pins to the LEDs, where I struggled similarly with a lot of trial and error. While adding my new GPIO code, I had some trouble getting it to run the way I designed it. It kept running the same piece of code over and over again. I realized it was because I was using a while loop that I had copied from our test program, which had no exit condition and just made the LED flash continuously. I replaced it with an if condition. So instead of running a piece of code while a certain statement was true, it would run if the condition was met and not repeat. I also learned a few basic Unix commands while learning how to run the program. After debugging one final time, it was finished. Next slide, please. You can start the video. This is a demonstration of my project. The Python code is run through a terminal window, and the LED is connected to the GPIO pins with jumper wires. What I'm typing is Python Morse _code.py. Starting with Python tells the computer I want to run the file using the Pi's knowledge of Python, and Morse _code.py is the name of the file I want to run. .py is the extension telling the Raspberry Pi it is a Python program. The program first prints the words, then prints dot or dash for each flash of light, along with the space between letters. And free spaces between words. It finishes by printing the message in WordStat. Next slide, please. Yeah.
Wonderful. Thank you so much. What questions do we have?
First time I used Raspberry Pi, I was 30-something year old, so I'm curious what inspired you to use the Raspberry Pi?
I like being able to see the visual components, and I want to actually understand how the physical pieces of computer work, which is why I ended up choosing a project that combined both hardware and software.
What part of the hardware and software did you enjoy?
I really liked testing it once I actually had it working, because it took a long time to get it.
I've got a question on Zoom that was really, really cool. I was wondering if while you're working on this hardware software project, if you had inspiration for other applications of either the same kind of technology that you built or new ideas.
I was mostly focused on using it in this specific instance, although the GPIO pins actually have many functions and can be used for a variety of things.
Yeah, I'm sure. Very, very cool. Thank you.
Well, it sounds like it took some time, like you said, that there's things that just weren't working. And I was wondering, like, how did you find the perseverance to keep going, you know? And like, was it like some little thing that you didn't think of? Was it like one thing that all of a sudden caused it to work? I wonder if you could just say a little bit more about that process.
First of all, I'd previously been using something called a key cobbler board and then a breadboard, which are some more components that really just transfer the electricity. And I was having trouble with those, and I ended up getting the jumper wires so I could conduct the electricity more efficiently. And then I just had the idea, well, what if I remove the breadboard and the key cobbler board and just connect it directly with the jumper wires? And that worked. I actually do not know why the breadboard key cobbler board setup was not working. So.
Thank you.
I have a question. We've listened to so many amazing presentations, and I'm wondering what connections you see with your classmates and the other kids, and what kinds of things that all of you guys can do next together, if you see any yet.
A lot of people have been working on Python, so I think that's probably some common ground if people wanted to collaborate on something.
I just have more of a comment about how Julie is amazing and figure out what she needs, and I hardly ever have to be involved. She'll find her resources, she'll go straight to Alberto, she'll ask for a list of things that she needs to have by a certain date, and she'll give Alberto a reminder, so give me a little reminder. So I feel like you're all set, like wherever you want to go, you're gonna get yourself there.
Yeah.